Bro, you know if you do.
All right, we are continuing with 1-3, which is dealing with continuity in behavior. And limits. So what I'd like you guys to do is make a quick little sketch of a graph that I'm going to give you right here. There's x. We'll call this f of x, right? Your y values. Not fx. We'll just call it y, the y-axis right now. So right now I'm going to draw a little function here. So here we go. Alright. Now you can get a ruler if you want. Right over here. Yeah, right there.
Anybody else want a ruler or anything?
This way.
1, 2.
So we have left. I want you guys to write left in right here. I want you guys to write right in. Now, I am calling this graph. I'm not giving you the equation that goes with the graph. I'm calling this graph f of x. Alright, so this graph is a function of x. Alright, as we look at this function, we are looking at what's called the end behavior. So let's look at the left end. Right now, right here, focus on that part. What's happening with this graph? It's going where? It's going up to what? To positive infinity. So you would say the limit of the function f of x, which is this graph, is going to equal positive infinity as x. All of my x values are approaching. This little arrow means as if x approaches. Now where are the x values going this direction? Negative infinity. And this is how you would write the left end behavior for this graph right here. So the y values are going up to positive infinity as the x values are being plotted towards negative. So what about the right end behavior? Where are we heading on the right end behavior? Once again, we're heading where? Going to positive infinity over here. See how it's going up? So we're going to say the limit of f of x is going to positive infinity as x approaches positive infinity. So as the x values are going to the right, which is going towards positive infinity, the y values are also going up. That's the limit of this function. It's going towards positive infinity. And that's what's known as the right end behavior.
So those are the two behaviors.
Yeah. So hey, every function is going to have a left end behavior and a right end behavior. Like what's it doing towards the right, what's it doing towards the left. All right, let's look at problem number 9. It says Ohm's law gives the relationship between resistance R, voltage E, and current I. So right now it has the resistance is equal to the voltage divided by the current. So right now for E, I'm putting voltage. All right. Now, in the USA, does anybody know what the consistent voltage that's going through your house is? Oh yeah, 120. So USA is 120 volts. What is Europe? It's 220. Now, you go to Europe, you got to take a what? You got to take an adapter for your device, whatever you're plugging in, because this right here, we have different voltage going through that system. Now, whenever you guys charge your iPhone or your Android, whatever you have a little adapter. That adapter converts this 120 to whatever it's operating at. Usually it's between, I think, 10 volts and it slows it down.
Yeah, so it
Right.
burns your phone.
Right.
Yeah.
And that's what's called the resistance. Okay? So it says, if the voltage remains what? The voltage remains constant. So what if we just say, our voltage is what? 120 volts. All right? Well, what if our current is at 10 amps? But then it goes to 100. And then it goes to 1,000, then 10,000, then 100,000, then 1,000,000.
So the resistance.
So the resistance keeps getting what? It keeps going down until eventually, what is it approaching? What do you guys think it's going to be approaching? How about this? Why don't you guys do 120 divided by 1,000,000 in the calculator? 120.
You get 1.2
divided by. Well, let's just do 10,000. What do you get? All right. Add another 0. So basically, what is in scientific notation? What does this mean? This means point 0, 0, 0, 1, 2. It's never going to get 0, but where is it approaching? It's approaching what? 0. Never hit it, but it's approaching. Now, remember we talked about end behavior? Is it ever going to reach infinity? No, but it's approaching infinity, right? So, this is what you guys can say. The limit of this function is going to equal 0. That's the limit. Even though it's never going to reach it, that's the limit. It's going to get to 0 as x, which means our current right here, is approaching infinity. So basically, in words, you could say this. The resistance approaches 0 as the current continues to increase. These words right here is basically what this means, okay? As it continues to increase towards what? Towards infinity. As that goes towards infinity, your resistance is continuing to get closer and closer to 0. Think of electricity like water, all right? Say the resistance is like the dam that's holding the water back. And so you can open up the dam to let water flow through. But guess what? If that current increases exponentially towards infinity, what's eventually going to happen to the dam? There's not going to be what? Any resistance left. It's just going to flow through. Okay? All right. Final problem that we're going to do as an example is going to be problem number 10. So I want you guys to look carefully at problem number 10. And it says, according to the U.S. Census Bureau, the approximate percent of Americans who owned a home from 1900 to 2000 can be modeled by this equation. All right, so this function, h of x, where x is what? X is the number of decades. So x is not the number of years, x is the number of decades. Graph the function on a graphing calculator and describe the what? End behavior. So here's what we're going to do. Before we graph something, we're going to graph the relevant domain. So what I want you guys to do right now is write x minimum. I want you guys to write x minimum at 0. I want you to write x maximum at 10. The reason why I want you to do 10 is because there are 10 decades. There are 10 decades between 1900 and 2000. That's why we're graphing from 0 to 10. For your x scale, I want you to do it at a 1. Now we're going to do y minimum, the y maximum, and the y scale. What's the least amount of, since this is dealing with what? It's dealing with percentage, right? The approximate percent of Americans who own a home. What's the least possible valid or relevant percentage? 0, right? Technically, 0% of the people in America could own a home, technically. Right? What's the maximum amount?
100.
So put 100. Let's put a scale of 10. So what we're going to do, before we graph everything, what we need to do is we need to set the window. So do the window settings first. So go to Window, X minimum, 0, X maximum, 10, X scale, 1, Y minimum, 0, Y maximum, you're at 100. And the Y scale is going to be at 10. One more thing, hit second, zoom. Let's turn our grid lines on so we can see our grid. Okay. We'll go back to window in case you need to look at the window. There's our window settings right here. Then I'm going to hit Y equals. And Zyla, could you tell me the equation I need to type in? Because I do not have that memorized. Negative point, how many zeros?
3.
1, 2, 3.
9. X to the 4.
X to the power 4. I'm going to right arrow. Okay.
Minus 0.09.
0.09.
X to the 3rd.
X to the third. Or X cubed, good.
Plus 1.54.
1.54.
X to the 2nd.
X squared. All right.
Minus 4.112. X
4.12x, got it.
plus 47.37.
47.37. Okay. So once you guys have that all nice and typed in, okay, you can look at your paper. Everything's typed in. Then and only then I want you to hit the graph button. Okay? And here you see a graph. So what we're going to do is, what I'd like you to do is I'd like you to look at this graph. All right? And on your paper, I want you to copy down the graph that you see right here. Remember, this is your x-axis right here. This is your y-axis. We're going from 0 all the way up here to 100. Remember, that's 100%. Right here we're at what? 50%. Here we're at 1910. All the way over here we're at the year 2000. Right here in the middle we're at 1950, 20, 30, 40, 50, and so on and so forth. 60, 70. Here we're in 1980. One of the best decades ever. Yeah, I want you to draw this on the page. All right, on this problem, everybody, it asked us to look for, go back to the problem. It says, describe the end behavior. Okay, so what we're going to do right now is we are going to describe the end behavior of this graph. So look right now, over here, this right here is the left end of our domain. Over here, this is the right side. Let's look at it, graphic calculator. What does it look like in this portion of the graph? Where is this graph going? Is it going up or is it going down? It's going up. So what I'm going to say is, you know what? I think that sucker is going up. That's where it's going. Over here, what does it look like this graph's doing over here? Going down. So it's going towards, that's going towards negative infinity. All right? Just look at that as your evidence. Okay? Because right now, why would I not, why did we start right here? Because this is the relevant domain. It goes from here to here. We started at what? 1900 and we went to 2000. So here's how I want you guys to describe it. So I'm going to put left. This is the left end behavior. This is the right end behavior. Okay? So you're going to write the limit of f of x. Actually, we'll call it h of x. I think it's called h of x in the problem. The limit of h of x. Remember, this graph right here is our function, h of x, that we type in, is going to equal positive infinity as x approaches, where the x is approaching negative infinity. Okay? And the right side will say the limit of h of x equals, where is this one going? Negative infinity, as x is approaching And so everybody, this is your answer for the left end behavior. This is your answer for the right end behavior. You're going to need to know how to describe left end behavior and right end behavior on your quiz. Okay? When we have a quiz, this is going to be one of the concepts that I'm going to be testing you on. Okay? All right. All you got to do is what? Look at what's happening on the left-hand side. Look at what's happening on the right-hand side. What does the arrow mean? As x approaches, right? So at this point, what I want you guys to do is look at your assignment. I want you to read through the problems. Remember, what are the three different types of discontinuities? What's one of them? Joint, okay? Not joint.
No.
Jump.
No.
So we have infinite, right? We have jump, and then we have removable. And you guys have all of those pictures in your notes of which ones they are, okay? So when it asks you for a type of discontinuity, it's going to be one of these three. Or it's going to be considered to be what? If it's not discontinuous, it's considered to be continuous. So you have the rest of the period to work on.